This lecture accompanies the General Building Trade Manual. Your instructor is Jack Creel, a licensed general building contractor, general engineering contractor, and masonry contractor with over 25 years' experience. This lecture will review the manual, page by page. Please be sure to have a pen and highlighter ready to take notes. We will begin with the Uniform Building Code located on page 9 of your trade manual.
The Uniform Building Code. This first paragraph talks some history of mergers, but the main thing I want you to know starts at about halfway through where it begins, but. Now get your highlighter out and let's highlight, but the bulk of the state's exam refers to the California Building Code, which is based on the UBC with California supplements. So as you're going through the exam, what you need to remember is that you're looking for the California Building Code. If your local codes are different, follow your local codes when you're at home doing the work there. But on the exam, you need to know and follow the California Building Code. Now let's go on to the building classifications. The UBC uses many ways to classify a building. One is by occupancy, the building's use or the type of activity involved in it. And there are 10 main occupancy groups. You can highlight those 10, A, B, E, so on and so forth. The primary thing to know, the general guideline, and this is in the next paragraph, first sentence, the general guideline for determining the class is the degree of hazard associated with the building. Highlight that first sentence. Read through the rest of this paragraph, and at the bottom here in bold, here's a principle that's really important to know. The more people, the higher the hazard rating. I'm going to repeat that. The more people in a building, the higher its hazard rating. Highlight that. Take a look at assembly. Assembly has the highest hazard rating. Why is that? Because it has the most people. It involves churches, assembly halls, theaters, so on and so forth. Business has a lower rating, not as hazardous. Educational, lower yet. Factory and industrial, lower. Now here's something, H, hazardous. Well, wait a minute, you just said that assembly was hazardous. Now you're talking about a hazardous building classification. Why is that? In these hazardous building classifications, or the H classifications, the occupancy is much lower. So if something happens to an H classified building, fewer people are going to be involved and be casualties. In an assembly or an A building, for example in a theater, you're going to see a much higher number of casualties. So it's more hazardous to more people. And in H, you'll see that the H1 deals with explosives and gets less and less hazardous as it goes through H7 and deals with corrosive or toxic materials. Again, read over that, get a sense of what they're talking about. Institutional and mercantile are the next couple of classifications. And as we turn the page, we get to the classification that most deals with what we do day to day, and that is the residential. And you're going to be dealing most likely with R3, which is the single family home. But let's back up to the R2, which is not used at present, so you can kind of put that in parentheses and understand that R1 deals with multifamily or apartment buildings. Quickly take a look at Group S, which is storage, and Group U, which is a utility building. Let's continue on and look at the miscellaneous UBC requirements. Section 106. A building permit is necessary and you need to submit plans and specifications for approval. Once approved, that set of plans is to be kept with the apartment for 90 days. Let's highlight 90 days. and that's 90 days after the completion of the project. The department must also, upon approval, give you a set of plans, and you must keep that on site, on your job site, such that the building inspector, when he does come out, can look at those plans and understand what is being done and what alterations were asked for by the building department. Section 310.4. This talks about the means of escape or rescue from a building. When we're talking about, especially about R1 and R3 buildings, this is very important. In residential buildings, all sleeping rooms below the 4th story must have at least one openable exterior door or window that can serve as a means of escape or rescue. Highlight means of escape or rescue. This is an important paragraph because it deals with the lives of people. The window must have a minimum opening of at least 5.7 square feet. And the net clear opening of the window, clear opening height of a window, must be at least 24 inches. The net width must be a minimum of 20 inches. Again, let's highlight those. At least 24 inches and a minimum of 20 inches. Now, look at the next sentence. It does not mean that your window can only be 20 by 24. A window that size will yield you only 3.3 square feet of opening space. So you need to have a window that gives you 5.7 square feet and cannot use a dimension shorter than 24 inches or less wide than 20 inches. There are some additional minimums. Read through the rest of the paragraph and understand those minimums. This will explain how you can and have to get to 5.7 square feet. And at the bottom of that same paragraph, there's another minimum. That opening, that window opening, cannot be any higher than 44 inches above the floor. Again, there's another item to highlight. Section 310.6, the minimum ceiling height in a residence. The minimum ceiling height is 7 foot 6 inches, or 7.5 feet. However, there are some exceptions. And again, I'm at the bottom of the page here. For example, the ceiling height for kitchens, halls, bathrooms, and toilet compartments can be as low as 7 feet 0 inches. Let's flip the page on to the next section. Section 310.9 deals with when you are under the obligation to install smoke detectors, and that occurs when you are at $1,000 or more in cost to do the work you're going to do, or you're installing and putting in a sleeping room. Read over that paragraph, understand that. That can be a question waiting to be asked. Now, sections 1001, 1003.2, 1004.2, and Table 10A. They're dealing with one exit per story. So let's highlight that as the subject of that paragraph. Number of exits needed. One exit per story. There are exceptions. In a second story of a dwelling, you need 2 exits when the occupant load is 10 or more. And you can read through the rest of that paragraph and understand what it's talking about. Now, section 1003.3.1. The exit doorway has to be a certain size. Its minimum dimensions are 3 feet 0 inches and 6 foot 8 inches in height. And once installed, that exit door must be able to be opened to at least 32 inches opening width. Again, highlight those numbers. Moving on to section 1003.3.3, stairways. Read through that, understand the minimums of 44 inches and 36 inches, and look at the minimum for handrail height. How high does your handrail have to be? It's 34 inches to 38 inches. And the minimum headroom clearance is 6 foot 8 inches. Section 1005.3.3 deals with vestibules. Just go ahead and read through that. And then section 1203.3 that deals with the natural ventilation in a room. There are, again, certain minimums required. For example, if you have a 100 square foot room, you need to have at least 1/20th of that in natural ventilation area. 1/20th is in the second line of the paragraph. Make a little highlight there. And the minimum has to be 5 square feet. Table 16C talks about the maximum live loads for flat roof areas. Read through that. Now on to the next page, section 1806. The top of a foundation wall supporting wood framing must be at least 6 inches above finish grade. And let's highlight that as well. Why 6 inches? 6 inches is a good, healthy distance that keeps the termites away. Keeps them away from that wood structure. Continue reading through that talks about some of the minimums for plates and mud sills. For example, you need at least a 1/2 inch bolt in your hold down bolts, your foundation bolts. Now in section 1900.4.4, we're talking about the minimum permitted thickness of a concrete floor slab on grade, and it is 3.5 inches. Many of you might think it's 4 inches because that's a common number thrown around, but it is actually only 3.5 inches. And that, of course, is the width of a standard finished 2x4, which is frequently used to form up that slab. Let's look at table 23, Roman numeral 4b. What that table says simply is that as you get more and more weight on a wall, that wall needs to have the studs put in more frequently with smaller spacing, for example, going from 24 inch to 16 inch, and possibly you might have to beef up that stud, going from a 2x4 stud to a 2x6 stud. Look at that table, understand what it says. You'll most likely see a question or two on the exam from that table. Section 2320. This is talking about a number of items, but the one thing I want you to highlight on here is about halfway through where the sentence begins, generally. Generally, at least 3 studs must be installed at the corners of exterior walls. And those are typically done with what's called a California corner. You may be able to find that in your information, but it is 3 studs. Now let's go on to table 25F. This deals with some minimums regarding stucco. When you put stucco on a house, you need to wait at least 48 hours between the first 2 coats, the scratch coat, which is the first coat, and the brown coat, which is the second coat. Highlight that 48 hours. And then the very next phrase, highlight another 7 days. That's the time that you need between the final coat, which is the finish coat, and the second coat, which is the brown coat. Table 25G and section 2508.1, go ahead and read through those, understand what they're saying. On to section 2512 on the next page, and we're talking about water-resistant boards, water-resistant drywall. Simply this paragraph is saying that in certain areas you cannot use the standard drywall panel. You need to use green board or water-resistant. Read through that. Understand what they're talking about as they talk about green panels or green boards. Section 3302 and 3313.3. What can you put in as fill? First of all, you have to get rid of stumps and roots before you put in any fill. and those have to come down to at least a depth of 12 inches. And then the largest rock or other irreducible material that you can put in to fill can be no bigger than 12 inches. That's pretty big. I wouldn't want to pick up too many 12-inch rocks and throw into a fill area. Section 3315.4, building pads must have a drainage gradient of 2%, that is 1/4 inch per foot. Section 3403.2, when making additions, alterations, or repairs to existing buildings, only the new addition or portion of the building being repaired or altered must conform to the current code requirements. That's a general rule. Add something on, only the addition needs to be governed by the current code. You don't have to go back to the old part and bring that up to code, except for this exception, and that is when we're dealing with smoke detectors. In that situation, there are certain requirements when you have to put smoke detectors in the whole structure, both the old and the new. Foundations for stud walls. You will most likely be asked a question or two on the state exam about this. Sometimes they're called T foundations, sometimes they're called stem walls. They basically consist of a horizontal unit, the footing, with a wall, the vertical unit. And this chart here, showing the number of floors supported, also shows you the demands on the stem wall or on the foundation and what size they have to be. Look over that, understand what that is, and then flip over to the next page. At the top there you'll see a 6132 rule. This was something developed by one of our students, and it's fairly clever, and it can help you understand how you step up in size and minimum requirements as you go from 1-story to 2-story to 3-story. Take a look at both of those pages. Again, you most likely will have a couple of questions that you need to know when you do that test. Now we will take up accessibility. Accessibility basically has to do with disabled folk and the help and the safety that they need. One of the main things in accessibility is ramps, getting people safely into their residences. And there's a number of items to pay attention to on ramps. One of the first things is how steep can you make the ramp? So the maximum slope for a handicap ramp is 1 in 12. In other words, for every 12 feet of horizontal direction you go, you can only come up by 1 foot. So it's not very steep at all, but that is the maximum. So let's underline that and highlight that. Let's look at the next sentence. It says there, ramps with a slope greater than 1 in 20 must have handrails at least 34 inches high and not more than 2 inches in diameter. And highlight that. That's a question that you most likely will be asked about. Look at the illustration there. Take a look at that. Understand what they're talking about. And let's look at something else here. Down toward the bottom of the page, bottom of that paragraph, just underneath that illustration. If no door opens onto a landing, top landings must be at least 60 inches long and bottom landings must be at least 72 inches long. What's that mean in overall size? Since the ramp itself needs to be at least 36 inches wide, that top landing will have to be at least 3 feet by 5 feet. And the bottom landing, the approach landing, will have to be at least 6 feet by 3 feet. Let's take a look at doors. When somebody is in a wheelchair and they're going through a door, there are significant obstacles. I myself was in a wheelchair a couple of years ago with a broken leg, and I realized all the barriers that there are. You don't realize what they are until you're in that chair. Unfortunately, I came out of it, but a lot of folk never have that choice. One of the items is that on the bottom part of the door, you need it to be fairly smooth, and to make sure that it's smooth, a metal plate is required. And that metal plate allows the chair to rub up against the door and slide across it. Otherwise, the chair is likely to get caught on the door and make for a considerable obstacle. So, what the code asks for is that plate on the bottom of the door, and that plate needs to be at least 10 inches high from the bottom of the door up. And that begins at the bottom 10 inches of the door, must have a smooth surface. Let's underline that and highlight it. Now, exit doors must be capable of opening a full 90 degrees and must be mounted so that the minimum clear width of the exitway is 32 inches. Let's highlight that as well. Take a look at stairways, read over that, and that pretty much wraps up accessibility. The next section is site work. In site work, we deal with soil types. There's a number of soil types generally classified as A, B, and C. And if you take your highlighter and highlight that first sentence under A, the most stable classification next to solid rock, that is type A. That is, of course, the ideal type of soil to cut into and work around. Now let's take a look at the illustration below type C there. It indicates the maximum slope that you can cut into soil. This is a safety factor, and it can be disastrous if you don't follow. What's indicated there in the illustration, that the maximum cut that you can make is a 20-foot high or 20-foot deep cut. And the slope all depends on the type of soil. The less that soil is likely to slide, the steeper the slope can be. Let's look at type A, for example. Type A is a very compact and very stiff soil, much less likely to slide and slip. It indicates that the slope is a 3/4 in 1. What that means is that you can go over 3/4 of a unit, for example, a foot, 3/4 of a foot, 9 inches, and at that point you can go up 1, or you can go up 12 inches. That's a fairly steep slope. But if you get into a type C soil, you're going to need to go to a much more shallow slope. Let's look at type C. Indicates that you can go over 1.5 inches or 1.5 feet, but you have to go up only a foot. Now later on we'll be talking about roof pitch, and the directions will be reversed. Instead of going over with the first number, we're going to go up with the first number on a roof pitch. For example, a 4 and 12, we would go up by 4. But in soil pitch or soil slope, that first number indicates that you go over and go up. And when we get into roof, I'll remind you again. One of the things that you do need to do in excavating is to fill back in again. And as you fill back in again, you need to compact. And one of the necessary items to compact soil successfully is water. It acts as a lubricant, allows everything to mix together and get tight. What's the correct amount of moisture in soil when you compact? Something that can't be put down in a quantified mode, but it is important to know that water is used to help compact. Too little water, you won't get enough compaction. Too much, you'll get a soup, and everything will flow all over the place. Let's flip over to the next page, and we're dealing with leveling. Leveling has to do with setting the house and the foundation as level as we can get it. And with today's instruments, we can get pretty exact. But let's look at the principle that the illustration indicates. We have a transit or leveling device in the middle of the illustration. To the left of the page, you have a benchmark, or what we might call a 0 point. Let's say, for example, we put the stick there, the benchmark stick, on the item or the rock, the point in the ground that we want to indicate as 0 to ourselves, and we read the top at 5 feet. Now, what we're trying to do, trying to find out what is the height of point A. when we turn our transit over and read the stick over at point A, it reads, for example, 3 feet. We do a little bit of math. We take 5 and subtract 3. That would indicate to us that that point A is 2 feet higher than our benchmark. And then we would go around the site continuing to do that and continuing to mark. That is what basically leveling is all about. Now let's look at excavation on the next page. When you excavate, you want to make sure that you don't cut into something that you don't know is there. And that has to do with any number of utilities that might be in the ground. You might be out in the boonies that you think are the boonies, and you say, well, there's nothing out here. I'm just going to cut into the ground, and you may find something down there that you did not want to find with that backhoe. In this area, in this state, what you need to do is contact what's called the Underground Service Alert, the USA for short. And the underground service lines will then be marked by this utility company according to the following color codes. So let's highlight that point there. Starting from Underground Service Alert, highlight that, and the underground service lines will then be marked by utility companies according to the following color codes. After that service has been done, you can look on the ground, you'll see perhaps red lines. That will indicate that there's electrical lines underground. If you see a green line, that will indicate typically a sewer line. Blue will indicate water, and so on and so forth. Concrete is the next section. Concrete is a mixture of Portland cement, water, fine aggregate, sand, and coarse aggregate, gravel or crushed rock. The water and the cement combine chemically and produce a paste or a glue. The aggregate does not react. It is inert. In other words, it makes no chemical reaction. The result is an ideal, strong unit called concrete. Now let's look at number 1 there, and I want you to underline that first sentence that says the strength of a concrete mixture depends on the water-cement ratio. If you read the rest of 1 and 2 and 3, it'll help you understand why it is so. How do we determine whether we have enough water in that cement? It's done with slump test. A slump test is a test that's been around for a long time, and if you look at the bottom of the page at the illustration, you'll get an idea of what is used and how that slump test is done. The can to the right is a can that's open top and bottom. When it has the big opening up, the concrete is poured in, the concrete that is to be tested, and then it's rodded, compacted a little bit with a special rod, and then the whole unit is turned upside down and the can is taken off. Now, what happens is that concrete, since it's wet, hasn't set up yet, of course, it will slump or sag down. And the amount of sag or the amount of slump is what is measured. The ideal amount is 2 to 4 inches. Now you can go ahead and write that into your book off to the side there. Depending on whether it's being used for a slab or a beam or whatever, a particular slump is given. Now, a 4-inch slump would indicate that the concrete is relatively liquid. A 2-inch slump would indicate that the concrete is relatively stiff. Let's look at mixing concrete on the next page. As you use concrete, you'll find out there's any number of mixtures. And generally, as it indicates on the page here, there are 4 different types of mixtures, going from rich to standard to medium to lean. And it's based on how much cement there is in the overall mix. As you can see, when we go from rich to lean, there's less cement. And if you take your pencil and write in off to the side there, off to the right, 1/6 for rich, and for standard 1/7. That is 1/7 parts total. Medium 1/8.5, and lean 1/10. That will give you a rough idea of the general ratio between cement and the other parts. If we look at a rich mixture, we see that we have 1 part of cement, 2 parts of sand or fine aggregate, and 3 parts of gravel typically. And we add those 3 items together, we come up with 6. We have 6 parts. And 1 part of that 6 is the cement, which gives us a rich mixture. So off to the right, put 1/6. For a standard mix, we have a little more of the aggregate in. We have 7 parts altogether in that mix, and the cement is the 1:7 ratio. So on and so forth. The medium would be a 1/8.5 ratio, and the lean would be a 1/10. Now, if you can remember that the standard mix is a 1:7, and anything higher than that gets into the lean, and anything lower than that gets into a rich mix, that should pretty much take care of you in this test. Pick up your highlighters, and that very first sentence underneath that table, let's underline that one. Concrete should be mixed for at least 3 minutes. There's a question ready to be asked. And then concrete should be poured a half hour from mixing, or within a half hour of mixing. Read over the rest of that, and let's look briefly at formwork. One of the questions may run into is, what is the most common material used for formwork? And the answer is plywood. Been that way for many years, still is today. So the answer simply is plywood. Make a note, highlight that first sentence underneath formwork. Reinforcement in concrete. The reinforcement in concrete is almost always steel. Steel has a great tensile strength. It also has some compressive strength, of course, but concrete has a very low tensile strength. In other words, you can pull concrete apart fairly easily, but if you put a piece of steel in it, it makes it much harder to come apart. And this has been done ever since we pretty much poured the first batch of concrete hundreds of years ago. Now, when you see reinforcing bar used in setting a slab or a column or whatever, one of the dimensions that is talked about is the size of the bar. So if you're talking about a number 4 bar, you're talking about a 1/2 inch diameter bar. Why is that? Very simple. The number indicating the size of the bar indicates the number of eighths of an inch that you're dealing with. So again, a number 4 would indicate 4/8 or 1/2 inch bar. A number 6 bar, that would be 6/8 or 3/4. Take a look at the chart there. That will explain it even more clearly. On the next page, read through this page, understand the minimum for lapping, simply overlapping the rebar, understand that. And let's take a look at this chart down on the bottom of the page. The concrete required to protect reinforcing bars. If you're going to put the if you're going to put the reinforcing bars into the concrete, you want to make sure that it's deep enough. If it's too close to the surface, it's going to what's called spall or pop the concrete off of itself, and the structure that you designed is not going to be any good. So if you're putting concrete footings down, and into those footings you're going to put reinforcing bar, you need at least 3 inches of coverage for the footings. So make a highlight on footings and 3 inches. Let's take another example, beams and girders. Beams and girders need to be covered at least 1.5 inches of concrete. Let's flip the page here. The next section in concrete is dealing with the 5 different types of cement. When cement is mixed into concrete, it gives off heat as the chemical reaction of the water mixing with the cement occurs. generally a standard cement type 1, and you can highlight this. Type 1 is specified when no type number is specified. So let's highlight type 1, standard, and the last sentence in the application. That's the standard used most of the time. Now, there's certain conditions when you use a different type of cement, and you would tell the mixing plant which type to use, or they would say, okay, we're going to change your type of cement because you have certain conditions. If you got into type 2, which is sometimes called the modified or the moderate, even though we have none in the book there, that generates less heat and takes a little longer time to cure. You can underline generates less heat. In some situations where you need a quick strength, the strength is usually achieved in 28 days, but if you need strength arriving in some 7 to 10 days, you'll probably be looking at type 3 cement, which is high early strength. Let's look at type 4. You might see a question, what is the slowest curing cement? And that would be type 4, also called sometimes the low heat of hydration type, indicating that it's a slower cure and gives off less heat. Look at all 5, understand those. You'll most likely end up with 1 or 2 questions about that. Now that we mixed the concrete, put it on the truck, and dropped it off at the site into the forms, there's going to be some 7 or 8 different steps to get the concrete to look the way we want it to look. And in these steps, we're generally talking about dealing with a slab of concrete. The very first step is screeding. So let's take out our highlighters and underline that number 1 there, screeding, striking off the surface to a predetermined grade. In other words, what we're doing is what most of us have seen or maybe done, is to drag a 2x4 across the top of the forms to get the wet concrete into the shape and into the form that we want it to be. The rest of the steps, next step would be bull floating and darbering, followed by edging and joining, and then floating, finally troweling and brooming. Need to know those and know those in sequence. Read over that, understand what each of those has to do, and you should do fine on the test. The next section that we're going to be talking about is carpentry and roofing. In carpentry, one of the basic terms is board foot. What is a board foot? A board foot is nothing more than a 1-inch board, 12 inches by 12 inches. That would be an example. Now, of course, wood comes in different sizes. To figure out what is the exact board footage that you have in a board, you follow this this formula where the thickness times the width times the length of the board is all divided by 12. Go ahead and highlight that there in the book. Then look at the example in which they talk about a 2x6 there. That should explain things pretty easily to you. And also look at the 2x8, since the 2x8 is a little different. Check both those examples. The next section we will be talking about is pitch and slope. One of the staff here, when they were doing examination of what the state wanted, asked one of the examiners, what do you want to know? What do you want the students to know? And he told him, if you get them to get straight pitch and slope, I'd be so happy. Well, let's get it straightened out. Let's look at the illustration at the bottom here. There are 3 important terms to know in pitch and slope. One is the rise, one is the run, and the other is the span. When we talk about a slope, we will compare the rise and mark the rise on this illustration, highlight that, and run. Those are the two items we use in slope. And we compare the two in a ratio. Let's make, in this example, the run to be 12 inches, right in 12 inches. And the rise is going to be 4 inches. That will give us a slope of 4 in 12. It's a very common slope. Now let's look at pitch. In pitch, we don't use the run. We use instead the rise, and we use the span. Highlight span. In this example, since the run is 12, the span is 24, twice the run. So put 24 right next to span. Now, to do the pitch, we take the rise, which is 4, and put it over the span, which is 24. And we reduce that fraction, and we come up with 1 over 6. So the pitch on this building is 1 in 6, whereas the slope is 4 in 12. Go over that, get that very clear. That will most likely be on the test. Let's go on to nails. Nails. Nails are coarse fasteners, and they come in many shapes and sizes. The thing we need you to know is basically in this second paragraph where it begins, penny sizes. That's in the middle of the paragraph there. Let's highlight. Penny sizes are denoted by a D, such as 6D or 5D, which specify the nail gauge or thickness and its length. So as you go from a 4D to a 6D to an 8D up to a 16D, that nail is getting longer and, of course, thicker. So the D indicates the size of the nail. Highlight that, understand that. And by the way, the D goes all the way back to Roman times to indicate penny. Denarius, an old Latin word for penny. Framing connectors. Read through that, understand what framing connectors are. I'm sure most, if not all of you, have dealt with a framing connector at one time or another. And today's framing connectors, especially those that are used with pressure-treated wood, have extra protection because the new pressure-treated types of wood are much more corrosive than the old types. That's something you need to be aware of. Plywood. Plywood is used and has been used in the construction trades for many, many years. It is usually denoted by its thickness, 3/8, 1/4 inch, 1/2 inch, 5/8, so on and so forth. Generally speaking, the more plies there are in a specified thickness of plywood, the higher the quality is. Turn the page, just take a look at platform framing and balloon framing. I'm not going to go into the details in this, but I do want you to read through that and look at the illustrations on the next couple pages here, indicating the difference between platform and balloon framing. Framing loads. We talk about a live load and a dead load, and it simply comes down to this. Once you have finished there as a carpenter and nothing is in the house, the weight on the structure is called dead load. So that would be studs, sheathing, beams, so on and so forth. Once you begin to load that house with items from furniture to carpet to people, that's considered live load. Just understand those two distinctions. You should do fine with that. And of course, read through framing loads. Let's flip a couple of pages here and pick it up at door and window framing. If you read through this paragraph right to the right of the window illustration, you'll understand some terms. That's what I'd like you to do. Go ahead and read through that. And note that the door and window sizes are called out as width by height. Width is always first. So when we talk about a 3/0 by a 6/8, we're talking about a door, of course, and that is width, 3 feet exactly across by 6/8 high. Remember that the width is always first. On the bottom of this page, where it begins for most interior doors, I want you to highlight that whole paragraph, read through that paragraph, understand that you need to make a rough opening 2 inches wider than the door size and 2 inches higher than the door size, and you also need to include the thickness of the finished floor. So for example, a 36-inch door would get a 38-inch wide rough opening, and a 6'8" door would get a 6' 10" opening. And if there's an inch of finished floor, then you'd add another inch. You'd end up with a 6' 11" opening overall. Flipping over to the next page, hanging doors. I want you to highlight this first sentence. 3 hinges are used for hanging exterior doors, and 2 hinges are used for the lighter interior doors. Let's highlight that. Read through the rest of that, and let's flip over to the next part, stairwell framing. We're into a part of the code which is quite specific about building stairways. Why? Because a stairway can be a very dangerous part in the house, even if it's built correctly. To keep it as safe as we can, over the years, any number of minimums and maximums have been derived. Let's look at that first paragraph. Let me start at the second sentence here, and I want you to highlight that. The rise of the steps must be no less than 4 inches and no greater than 7 inches. Highlight that. That's your rise, your up dimension on the stairs. The run of the steps must not be less than 11 inches. Again, highlight that sentence. And for uniformity in the stair construction, the greatest and smallest riser heights shall not differ more than 3/8 of an inch. Why is that? Because as soon as we start up a set of stairs, we automatically adjust our foot lift for the height of the stair. We just do it automatically. We never think about it. And if that height changes, we can't pick that up until we trip on the stairs. That is why that uniformity and that tolerance of 3/8 of an inch is in the code. Looking at the bottom paragraph, when placing the stair frame, the first riser must be shortened by the thickness of the tread. This is known as dropping the stringer. If you read that paragraph, I think you'll understand what is being said there. And once you've read that, let's flip on to the next page. Roof framing requirements. Read through that paragraph. Understand that you need to know your spans and weights and so on and so forth. Roof types. If you flip the page to the next page, there's an illustration on that page and the following page of different types of roof. Pay attention to gable, pay attention to hip, which is actually in that first indication there. And understand that a hip roof will slope in 4 directions. And what I'd like you to do right now is about halfway down through that first page, highlight hip roofs slope in 4 directions. Again, look through these illustrations, understand what we're talking about, and then let's go on to shingle terms. Shingle terms. A shingle has any number of terms, and if you look at the illustration and understand what they're talking about, you should get the terms that you need. Know that the butt is the lower exposed edge of a shingle. In the very first sentence there in the first paragraph. Let's underline that. Roof trim. One of the things that's important to know is the terms around a roof construction. And let's underline that again, the first sentence of that paragraph. The exterior finish surrounding the eaves is known as the cornice. And there are any number of variations on a cornice. Read through the rest of that paragraph, and let's move on to roofing materials. Roofing materials, there's any number of different types, the asphalt shingle being pretty much the most popular. Wood shingles and shake shingles come in a couple of different varieties and grades. And if you look there, you'll see that the blue label is the highest quality, the premium grade. The red label is the medium grade or the good grade. And the black label is the lowest grade. Understand those and know those. And the very next paragraph where it talks about wood shakes, read that paragraph, and at the end, that last sentence, it begins with as with shingles. Let's underline as with shingles. 2 nails are used to fashion each shake. Read through the rest of that, understand the classifications at the bottom of the page, and let's move on to brick surfaces and sizes. The next section is masonry. Brick surface and sides. If you look at the illustration, you'll see 6 terms. The 3 terms, side, end, and face, are the ones that are most commonly used. If you understand those, I think you'll be fine. So let's underline and highlight side, end, and face, and know what part of the brick they're talking about when they use that term. Read through the rest of that, paying attention to non-modular and modular sizes. And then let's get into mortar and grout. Mortar and grout. Understand the difference between the two. Grout is what's poured into the cells of a concrete masonry unit or a concrete block. And it is also poured between 2 brick walls. And those 2 brick walls are technically called widths. You'll see that in the next couple of pages here. Grout is hidden. You'll never see grout in the finished wall. It's always hidden. Mortar, on the other hand, is what holds the 2 pieces of brick together and or the 2 pieces of concrete masonry unit, 2 concrete blocks together, and the mortar is always seen. Mortar is generally a little thicker than grout. Grout is a little more soupy and easier to pour. Let's take a look at some of the things we want to highlight. In that paragraph that begins, mortar and grout mixed at the job site should be mixed for at least 3 minutes. Let's highlight that. That's a question ready to be asked. And for no more than 10 minutes in a mechanical mixture. Again, let's just continue with our highlighting on that. Let's skip the next sentence. Don't worry about highlighting that. But where it begins, mortar should not be used 2.5 hours. Let's begin highlighting that again. And more water or more after water is first added to the dry ingredients. Flip over to the next page. We're going to talk about patterns. The pattern of bricks in a wall is called the bond. Best thing right now is to simply flip your page and look at the brick patterns on the next page. Those first 3 illustrations show the common bond, the English bond, and the Flemish bond. When you see the brick going in this direction, such that the long edge is this way, that's called a stretcher. When you see just the butt end of the brick, as in the common bond, or particularly in the Flemish bond, that indicates that the end of the brick is showing. Take a look at those pictures. I think you'll understand what we talk about in bonds and understand the difference between common, English, and Flemish. You might also look at the bottom of that illustration page such that you know the different terms. Coarse, width, that's a little bit of an unusual term that indicates a wall of brick. In that illustration there's 2 widths there. Stretcher, so on and so forth. Let's flip over to the type of brick. The type of building brick. There are generally 3 different types. One called severe weathering, one called moderate weathering, and one called negligible weathering. Simply highlight SW, MW, and NW. If you're working in an area where you're subject to a lot of frost and freezing, and you're putting up exterior brick, you will want to most likely use SW brick. Read through that chart, understand what the chart is trying to give you. Of a little bit of interest is the joint finishes. I've always been fascinated by that. Quickly look through that. And now we're talking about concrete masonry units, also known as CMUs, or simply sometimes as block or concrete block. For example, when masons get together, you'll hear them saying, well, I'm laying block today. That indicates they're laying these concrete blocks that are about 16 inches long, about 8 inches high, about 8 inches thick. That's the most common size. There's several different sizes, but that's what we're talking about here. Highlight that it measures 8 inches by 8 by 16. That's in the second sentence. Let's drop down to the third paragraph where it says CMUs should never be wetted immediately before or during placement, unlike other masonry materials. Underline and highlight that. Why is that? It's a shrinkage concern. Hard to believe, but if you wet a concrete block, it actually expands a bit. And when it dries out, it returns to its original size. So if you lay it up quite wet, or if you've wet it, or if it's come in from the rain, and it's still wet when you lay it up, it's going to be a little bit expanded. And it's going to shrink, and its neighbor is going to shrink, and its neighbor is going to shrink. The end result is that your whole wall will shrink by just a little bit. Hardly anything to measure, but it will create cracks. Cracks you don't want, and cracks that may cause a redo of the job. Read the rest of that, understand what is in those paragraphs, and let's move on to the different types of mortar for unit masonry. This list shows 5 different types, starting from a high compressive strength of 2,500 psi at the top, which is, of course, the type N. And let's highlight that. Type N, the highest compressive strength. Maybe a question there that you get asked. What's the highest compressive strength? Type M, masonry. Through S, through N, through O, and through K. Most likely we'll never run into O or K unless you should be doing very specific historic preservation. And in that situation, they may want a very soft mortar to match the original mortar. It's a very interesting item, but most likely you won't see it. Now let's flip over and get into electrical. If you read through this section, it'll give you a background of what you need to know about electrical. About a quarter of the way down the page, we have 3 formulas. I want you to circle the middle one. And understand that E stands for electromotive force, or voltage. And I stands for an old term called inductance, or now usually known as current, and R stands for resistance. These 3 electrical items may be asked of you on the test, and if they ask you to determine the electromotive force or the voltage, use that formula there in the middle. If they ask you for the current or ask you for the resistance, you can develop the formula you need from that formula in the middle. Let's do a sample problem. The resistance of a simple circuit, 20 ohms, and the voltage with 120 volts. So we convert the middle formula into I equals E over R, or current equals voltage over resistance. So we put in 120 over 20 ohms, and we end up with 6 amps, the correct answer. Power is very much the same sort of mathematical application. Again, the easiest formula that I find to deal with is the first one, P equals E times I. P equals the power typically expressed in watts. E indicates voltage, and I indicates amperage or current. Again, a simple and sample problem at the bottom here. A 60-watt lamp connected to a 120 volt circuit will draw how many amps? So you use the formula I, or current, equals power divided by voltage. You put in your power, which of course is 60 watts. Under that you put your voltage, 120 volts. Do the division, you end up with a half an amp, typically shown as 0.5 amp. Flipping over to the next page, circuits. Let's talk about circuits. On this page here, there are some details here that would be of more interest and more demand to an electrician. However, there are some items that you do need to know. There are two different basic types of circuits. One is a series circuit and one is a parallel circuit. If you look at the illustrations and read through this, I think you'll understand the difference between the two. Looking at grounding toward the end of the page there. Grounding is an important safety device. Let me have you underline the very first sentence here. A ground fault circuit interrupter, a GFI or GFCI, is designed to protect the user from a dangerous shock. If there's a problem in a circuit, it reads that problem, and within 1/40th of a second, it cuts off the power of that circuit and can save someone from a heartbeat being interrupted by the electrical shock or breathing being stopped by the electrical shock. That's an important item to always pay attention to. And let's go on and read the next paragraph that begins an electrical panel and underline it. Electrical panel must be grounded to an underground cold water pipe, if present, and with an embedded grounding rod. Now that's something that's fairly basic in electrical installation. You ought to know that. Finish out the rest of that page. Let's take a quick look at the next page. On the next page we have diagrams showing how to measure electrical force. The first diagram shows the measure of voltage, the second one shows the measure of current, or amps, and the third one shows the measure of resistance, or ohms. Read through those, and then look at the next page and glance over the different meters that are available to be used to measure electrical forces. Now let's get on to the page that starts wire and cable. In the middle of that first paragraph, it starts, wire sizes are described in terms of the American wire gauge, or AWG system. Let's highlight that sentence. Wire sizes are described. Continuing on, in this system, the larger the AWG number, the smaller the wire diameter. So if you're dealing with a 14 and a 12 AWG wire, the 14 is the smaller wire and the 12 is the larger wire. As you get down into the smaller numbers, the 8s, the 4s, the 6s, the 2s, it turns into zeros. The biggest size wire would be a 4/0 wire in that list that's on our page there. Understand how as the numbers get lower, the wire gets bigger. Read through the rest of that, understanding what's on the page, and let's take a quick look at electrical connections. Electrical connections. Let's make a couple of underlines over some important numbers. When you're dealing with electrical cables, the sheathing, or typically the white plastic or the colored plastic over the wires, must be removed some 6 to 8 inches. Let's highlight that. And then you use a wire stripper to remove a 1/2 inch to 5/8 of an inch of insulation on the wire itself, such that you can make the actual electrical connection between two wires. And underline that 1/2 inch to 5/8. Read through the rest of this, understanding what each paragraph says, and then let's flip over to conduit. Electrical conduit. On this page it indicates 4 general types of electrical conduit. First being rigid metallic conduit, the next being PVC or non-metallic conduit. That's typically found in a gray color, a medium gray color. EMT, which is electrical metal tubing, fairly lightweight. And then a flexible conduit, flexible metal conduit. Those first three can be buried into the ground. And if you flip your page, you can see the demands for burying conduit and cable. You only need to bury rigid metal conduit 6 inches, but if you're dealing with non-metallic conduit, PVC, you need to bury it at least 18 inches. And if you're dealing with direct buried cable, and that is basically a heavy-duty Romex, and it has specific indications on it that it is allowed to be buried. Make sure that if you're ever dealing with it, you're dealing with cable that can be buried. That needs to be buried to at least 24 inches. Now, staying on this same page in which that illustration about finish grade is, but going to the top of the page, we're talking about the National Electric Code. It has certain demands. Let's look at one of the demands, and that is in section 210.52a toward the top of the page. That's underlined 6 feet. That's underlined 12 feet. Those are some basic units of measurement that indicate exactly where outlets are to go and how frequent they are to go in a room. Read through that. That will help you understand how frequent you have to put in an outlet. Now we're dealing with section 210.52b. Take out that highlighter. Let's highlight that first sentence. I'll read it to you. 2 or more 20 ampere circuits for all small appliance loads are required for the kitchen, dining room, pantry, and breakfast rooms of a building. Now understand that they're talking about a group there. You do not need 2 circuits for each one of those rooms. Read that carefully. It's 2 circuits for all of those rooms. Read through the rest of that paragraph. And section 300.5 deals with, in words, what we looked earlier about on how deep we have to bury rigid conduit and other types of conduit. Let's flip over to the next page. Section 310.5 talks about the minimum size conductor for ordinary wiring. Let's underline and highlight that whole short little paragraph of a line and a half or two. You may well see that question or a similar item on the test. Read through the rest of this on the page here, dealing with non-metallic sheath cable, Romex, and understand what they're talking about, particularly about the minimum support needed for Romex in a house construction, indicated by the illustration at the bottom of that page. Flipping over the page and looking at Electrical Safety Order 2946, if you're ever in a situation where you're dealing with very high voltage, and on this chart it shows you start at 600 volts, which is quite high, there's some minimum number of feet that you have to be away from that. Read through this and get a quick understanding of what you need to do there. Getting on to the next page, there's a whole list of electrical symbols. Should go through these and understand what they are. Don't necessarily have to know and fully memorize each and every one, but you should be quite conversant and able to understand the more common ones, such as the switches, the three-way switches, the duplex receptacles, the lights, so on and so forth. And let's flip over to the next page, and we're going to be dealing with abbreviations for common electrical conductors, fixture wires, cables, and conduit. Now if you look at this, it looks like just a hopeless case of a bunch of letters, but let's drop down to the bottom of the page here, and it shows us the code. Here's the decoding information at the very bottom of the page. So F stands for fixture, FF stands for flexible fixture wire, so on and so forth. For example, if you look at the third one from the bottom, that talks about THW. That indicates that it's a thermoplastic insulator. It has a heat resistance of 1H, and it is also weather resistance. When I say a heat resistance of 1H, that indicates 15 degrees of centigrade heat resistance. Let's flip over to the next page, which is plumbing, and we'll deal with that. And now we're in the plumbing section. Let me give you a little pop quiz. You go to the store, you grab a gallon of milk, and you walk out the door and throw it onto your front seat. Tell me, how much weight have you dragged out onto your front seat? 5 pounds? 10 pounds? 7 pounds? Okay. By this chart on the next page, you've taken out about 8 1/3 pounds of weight in that 1 gallon of milk. And that's an item that you ought to take to the test with you. Keep that in your head. It's something you may well be asked about. And, of course, you know that boiling temperature of water is 212 and freezing temperature is 32 degrees. And again, of course, that's in the Fahrenheit scale. And another item you should notice, the volume of 1 cubic foot of water is about 7.5 gallons. Now, when we look at vents and traps, and I want you to read through that and understand what they're talking about, the main thing that vents and traps are used for is to trap sewer gas. If you've ever done a little bit of plumbing on an older house and you've undone the plumbing system, pretty soon you'll notice that the sewer gas comes up and it's pretty stinky. Well, number one, you don't want sewer gas in your nice new home. And also, you might not know this, but if you get enough sewer gas, it can be actually explosive. So, to keep those two events from happening, from having a little explosion in your bathroom or to have a stinky smell in your bathroom, we use vents and traps. And if you read through that, you'll understand some of the mechanical uses that are employed to keep that gas where it needs to be. Let's flip on to the next page and deal with drainage. The drainage system of plumbing. Let's look at this first paragraph. We're talking about a drain, a drainage system. Let's underline these items. A building drain and a building sewer. This is kind of like that old song, hip bone connected to the knee bone, connected to the shin bone, connected to the ankle bone. Well, a drain is connected to a drainage system. A drainage system is connected to a building drain, and the building drain is connected to the building sewer. If you read through that paragraph, I think you'll understand the connected items and how they work with each other, and the distinctions between the four of those. There are a couple of different types of drainage materials. One of the oldest and one of the ones still used today is cast iron. That's number A, or letter A. And several between galvanized steel, so on and so forth, copper and brass. When we get down to G, ABS, we're getting into plastic. ABS is typically black, although less and less of that is seen today. And more of the PVC or the white plastic is used simply because of its availability, its resistance to chemicals, its ease of use, so on and so forth. You might run into nicer houses where they ask that the vertical drains be done in cast iron rather than PVC, and that's simply because cast iron is quieter. And rather than hearing somebody flush the toilet in the PVC, those folks who have those houses prefer to have a quieter drain system. Flip on to the next page, copper tubing. Let's look at copper tubing. It is one of the most popular plumbing modes of getting water into and out of the house. If we look at the first paragraph there, we'll see that there are 4 different designations, the K, the L, the M, and the DWV. Let's underline the second sentence. Type K has the heaviest wall thickness, and type DWV has the thinnest wall. And L and M have in-between thicknesses. If we drop down to the chart just below, we can see how the K is used, how the L is used, and the M, and so on and so forth. Now the K, the L, and the M are typically used in a pressurized system of supplying water. And the DWV, since it has the thinnest wall, is not used in a pressurized system. Read over that page. I think you'll understand fairly clearly how those different types are used. Plastic pipe. Several different types of plastic are used to make pipe. For example, polyvinyl chloride, PVC, one of the most popular. Chlorinated polyvinyl chloride, CPVC, used for supplying water in pipes. Acrylonitrile butadiene styrene, ABS, typically seen in black applications, or that is to say it's black pipe. And polybutylene, PB. Read through the rest of this, understand some basic differences between those four different types, and then let's go on to cast iron pipe. Cast iron pipe is an old type of pipe. It's proven, it's still used today, but what you'll be hard-pressed to find is somebody doing a lead application as indicated in this illustration on the bottom. If you ever see anybody doing that, you're seeing an old pro, and this guy is probably someone's great-grandfather. I've dealt with several plumbers, older guys, and they say, no, I don't do this system. I don't even have the tools to do that. So, again, if you see that, you're seeing quite a show. Appreciate it. Let's flip over to the next page. Water heaters. In this first paragraph, it defines what a water heater is. And on the last sentence of the first paragraph, let's underline this. You must have a permit to remove, replace, or install a water heater. When you do that, when you replace a water heater, you're also required to put in a temperature pressure relief valve. And that's a safety item. There have been a few too many explosions of water heaters causing damage and injury. Read through this, understand what you need to do. There's some additional requirements as you read through these short little paragraphs. When we get down toward the end here, there's a paragraph that starts, if installed in a garage. That's the third paragraph from the bottom. And let's underline that. Any part of the water heater that generates a flame, glow, or spark must be at least 18 inches above the floor. Why is that? Well, it's very common to find in a garage, particularly an enclosed garage, vapors of some kind that are explosive. Could be gasoline vapors, could be propane vapors if you're on propane. These two vapors are heavier than air and will sit on the floor of a garage. If you have that flame or source of heat or ignition at 18 inches or higher, there's less of a chance of an explosion. Not a guarantee that you won't have one. It's just a safer application to keep that area safe. Read through the rest of this, particularly the item about showers. Now let's go to the Uniform Plumbing Code, the UPC. Let's look at section 605. I'm not going to go into detail on that. I simply want you to read through it. It talks about a couple of different kinds of valves. Understand that in certain situations a full flow valve is necessary. And let's look at section 608. I'm going to have you underline several different things in that. And we're going to start at a service pipe, or the second sentence in that paragraph. And it begins, a service pipe is run from the street main and connected to the building supply pipe. The water supply pressure must be at least 15 psi. I want you to underline that whole sentence, and I want you to highlight or circle a service pipe and 15 psi. Let's go on. There's another psi pressure, and that's 80 psi. That's the max that you can have. Beyond that, you need a pressure regulator. Underline that, pressure regulator and 80 psi. Read that paragraph, understand that it's bracketing the different pressures that can be in a house. Let me have you read over sections 701 and 903. That deals with the different types of materials that can be used for drainage pipe and for vent pipe. Now let's look at tables 7.3 and 7.5. You'll find those tables actually on the next page or two here, but I first want to go through the paragraph a little bit with you. If you go down a couple sentences, it begins, one fixture unit is equal to 7.5 gallons per minute. And that's simply a measure of how much water is going through the system. So if you take a bucket that has 7.5 gallons in it and you pour it into a fixture and it takes about a minute to go through, that would be a 1 unit fixture or a 1 fixture unit. And again, that's equal to 7.5 gallons per minute. A bathtub is a 2 fixture unit. It will deal with about 15 gallons per minute. Again, I want you to read through that. And let's get over to those tables 7.3 and 7.5 here that list the different types of fixtures and what their fixture unit rating is. You will see that wash basin is the only one, and it's about the 5th one down there, that has just 1 fixture unit. So that's the smallest amount of water going through any of those fixtures. Most of them are 2, and a water closet, or that is to say a toilet, provides for 6 fixture units, other than the smaller 1.6 gallon. Table 7.5 indicates what size pipe is needed for those fixture units. For example, if you have a fixture unit that only has a 1 fixture unit demand on it, you could use a 1 1/4 inch size pipe. But if it has a 2 fixture unit to it, then you'd need a 1 1/2 inch pipe. Read those tables, understand what they're saying to you, and let's continue on and look at the plumbing symbols. These are a lot like the electrical symbols. Just something that you should get a general idea of what they're talking about. They're pretty straightforward. Take a look at those. Look at, for example, the kitchen sink or the laundry tub, corner lavatory. A lot of those are fairly obvious. Let's go on to HVAC, short for heating, venting, and air conditioning. Units of heat. The most popular unit of heat used in the HVAC trade is the BTU, or the British Thermal Unit. If you go down about halfway through the paragraph there, it begins the BTU. Let's underline BTU. The unit most commonly used in the heating, ventilating, and air conditioning industry is the amount of heat, and let's underline that, is the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. Let me underline that. You may well see that as a question on your test. Then there are generally 2 types of heating fuels, natural gas and liquefied petroleum. Natural gas being a lighter weight and gives a smaller amount of heat per unit burned, whereas propane is a heavier weight gas. Kind of something like the difference between burning pine wood and oak wood. For the same weight, you're going to get more heat from the oak than you will from the pine. Now, since natural gas is odorless, an odorant is added so that leaks can be smelled before dangerous concentrations are reached. And that sentence is the last sentence of the second paragraph. Let's underline that. Since natural gas is colorless, or odorless, and colorless, an odorant, so on and so forth. The next paragraph speaks a bit about LP gas. I want you to read through that. And let's underline, unlike natural gas, this is the second or third sentence in there. Unlike natural gas, propane is heavier than air. A propane leak is considered very dangerous because propane gas will accumulate in layers at the floor level. Underline that sentence. HVAC appliances. I want you to read through that, see what they're talking about. A particular item to underline is that last sentence, to minimize noise, the last sentence in the last paragraph. To minimize noise, the compressor of a central air conditioning unit should be located on a slab outside the house. The next section is refrigerants, or the gas/fluids that are used in air conditioning systems. There's several different types. This is rather esoteric, it's rather complicated. What I want you to go away from after reading this is that refrigerant liquids or gases absorb heat, and that is how they end up cooling. That's the basic action, is that they absorb heat. Let's drop down a couple of paragraphs. In that third paragraph, in the last sentence of the third paragraph, it begins, CFCs, or chlorofluorocarbons, were banned from manufacturing, and let's underline that, and because of environmental concerns are being phased out. Read through the rest of that section, and then let's flip over to the Uniform Mechanical Code. I want you to read that first paragraph there, and then let's drop down to section 303.1.3. What are we dealing with? We're dealing with that 18 inches above the garage floor item again here. Let's underline that last sentence or two. Starting at etc., at least 18 inches above the garage floor. This regulation most commonly applies to hot water heaters. Underline that. Now that's put in again. Why is that? Because that's such a safety item. If you violate that, if you put it right on the floor, you are really risking someone's life. As I have you read through the rest of these items here, you'll see some items are not a life or death matter, but this could well be a life or death matter, and in those items the code is very tough, and you really have to pay attention to that. As I said, read through the rest of these items, gives you some ideas of some basic demands of the HVAC trade and the Uniform Mechanical Code. And then we're on to drywall and plaster and insulation. When dealing with drywall, we're really dealing with three different types of drywall. The regular drywall, the type X, which is a fire-rated drywall, and that's typically 5/8 thick and thicker, and the water-resistant board, sometimes called green board. Read through that, understand those distinctions. You also should understand the different sizes. And toward the bottom here, toward the bottom third, it begins, generally drywall nails should be spaced a maximum. Let's underline that sentence. Generally drywall nails should be spaced a maximum of 7 inches on center on ceilings and 8 inches on walls. Now I'm going to skip down to the next paragraph. It talks about the different types of drywall screws. Type W, Type G, Type S. Read that. And underline that last sentence. The maximum spacing for screws is 12 inch on center for ceilings and 16 inch on center for walls. There's 4 numbers in these last 2 paragraphs that you need to pay particular attention to. One is 7 inch on center for nails, 8 inch on center for nails, and that's ceilings and walls. And then 12 inch on center and 16 inch on center. Again, this is for screws, for ceilings, and for walls. There's one short little paragraph there that talks about drywall screws, how far to drive them. Read that. The distance that it should have a little dimple in the wall of about a 32nd of an inch. maybe the thickness of a fingernail, a little bit thicker than that. Plaster. Plaster is a mixture, a wet mixture of Portland cement and gypsum, and it is applied in several different modes and ways. There's a base coat, then a brown coat, and then a finish coat. And there's 4 modes or 4 kinds of plaster that are used for a base coat. That is listed under the base coat gypsum plaster section here, and it's neat, wood fibered, ready mixed, and bond. This is something you're probably not going to run into a lot, but you're going to need to know just in case one of those questions comes along in the test. You might use some little memory device on that situation. For example, is the wood neat and ready for bond? I'll repeat that. Is the wood neat and ready for bonding, meaning the first coat? That would indicate those are the base coats. And in the finish coat, you're talking about a gauging plaster or keen cement or mold. Again, you might need to use a little memory device. And on something like that, you might say, let's gauge and be keen and mold that finished surface. So you just might have to do a little trick memory device to get those into your head long enough to get to the test. Plaster coating. Let's jump down a couple of a couple of paragraphs, but I do want you to read those first 2 paragraphs. But let's highlight something fairly important here. In 3-coat work, and we're talking about 3-coat, that means a scratch coat, a brown coat, and a finish coat, in that order. The scratch coat stiffens the lath, forming a foundation. Let's underline that. And before it sets, it is scratched in a cross-hatched pattern to make a rough surface, and that's why it's called the scratch coat. Underline that and know that. It'll help you in the test. And now let's flip over to insulation. One of the main units of measuring insulation is the R unit, or the resistance to infiltration of heat or cold. The higher the R, the better the insulation, and the less fuel you're going to use to heat or cool your building. The chart here in the middle of the page indicates some dozen or so different types of materials, starting with the best insulating, the highest R value, which is polyurethane expanded, and getting all the way down to an air layer, which is some 6 times less effective. You need to go through that, understand that the rigid foam types are at the top, then you get into the loose fill and the bats in the middle. And as you get down lower and lower, you get into basic building structures such as wood, softwood or hardwood, and then finally, of course, your air layer. Read through the rest of this page, understanding the different concepts there and the different products. And then let's get over to painting and decorating. Painting and decorating. I want you to read through these pages here. I want you to understand the basic characteristics and the basic uses and advantages of one type of paint over the other. For example, number 2, oil-based paints and alkyds. Those are particularly good for covering up stubborn stains, although some stains will need a different type. But as I say, read through, get a general idea of the different types of paint here. And on the next page, surface preparation. There's a number of different ways depending on the substrate that you're going to be working with. Read through that. For example, gypsum board needs typically a PVA, a polyvinyl acetate sealer. You get that pretty much at any paint store or supplier. And a metal or ferrous metal or an iron-based metal needs to be primed with an alkyd, that is to say an oil-based metal primer. Read through those, understand the differences, get, as I say, a general idea. Troubleshooting paint problems. Let's look at our chart here on this page. Alligatoring, or checking as it is, small scale alligatoring, is a problem that comes up often enough. One of the reasons is, first reason there in the list, is applying paint over a wet coat. You think that the prior coat is dry enough, you put on your new coat, and after a while you find out it's looking like the back of an alligator. You're not happy. Although in some situations, certain creative artists and creative painters will want that, we usually don't want that in our paint. We want it nice and smooth and even and long-lasting. Cracking and scaling is another problem. Blistering and peeling, the third one down, is a problem. That is the most common problem, the most common paint problem, blistering and peeling. And it almost always comes from water between the paint and the substrate. So if you paint a piece of wood that is still too moist, hasn't dried out enough, you're going to have most likely blistering paint. Or if you paint a piece of wood that is dried out enough, but moisture from weather or from bad construction practices has seeped in and is now coming through the wood and popping off the paint, you're going to end up with blistering. Read through the rest of the troubleshooting. On the next page, there's an item called chalking. That's a problem only if excessive, because a lot of exterior paints are designed to give a certain amount of chalk off and help self-clean themselves. As I say, read through the rest of this, get a general understanding of what's being talked about in this troubleshooting section. Now let's talk about wall coverings. Read through this. It talks about a couple of different products and the different types. And down toward the middle of the page, I want you to underline, do not apply wallpaper directly to new drywall or plaster surfaces. You need to put on a prep of one sort or another, either a wall sizing or a primer or an oil-based paint is necessary. So make sure that you get that preparation in before you put that wallpaper out. Otherwise, you're going to have problems of it peeling back off on you. And let's underline the very next sentence as well, too. Most sources do not recommend papering or painting over old wallpaper, especially if it is in poor condition. The recommendation is to remove the old wallpaper first and then start again. Read through the rest of that, understand what is being said. And let's go on to the finished work of carpet, tile, and cabinet work. Finished work. Carpet. Read each one of those paragraphs, understand how they're installed. Read through tile and take your marker and underline the numbers: 15 pound, 4 mil, 24 hours, 3/4 inch to 1 inch thick. Those are your highlights. Read through, let those be a cue to understand what you do with tile and how it is installed. And then cabinet work. Let's underline that first sentence. The standard height for base cabinets is 36 inches high and a standard depth of 24 inches. Read through the rest of that paragraph. Then on the next paragraph where it talks about wall cabinets generally 12 inches. We can say 12 inches deep as well. They're generally 12 inches deep. And 12 inches to 30 inches high, so on and so forth. Again, read through, underline the numbers. Those will be little cues to you. Now let's flip over to the energy conservation standards. Energy conservation standards. This may seem a little dry and you may want to rush through this, but more and more we're going to be getting into a need to pay more and more attention to energy. Read through this, pay particular attention to that introduction where it says 4.4.0. put a nice big line around that. That's a good definition, a good general explanation of what energy is about. Read through the requirements, the location of insulation, and as you do, look at the illustration on the next page of the house. And each one of these items from 1 through 10, exterior walls, ceiling, so on and so forth, are indicated by the little numbers on the diagram of the house. For example, knee walls adjacent to heated spaces, that's up in the attic area or the second story area on the figure 9.2. As I say, read through that, get a good general understanding of what they're talking about. Solar heating. Let's read that first sentence. It's rather amazing. It has been estimated that every 20 minutes enough solar energy reaches the United States to meet our heating needs for an entire year. So the more we're able to use solar heat, the better off we'll be, the less our fuel costs will be. And let's look at two general distinctions between solar systems. One is a passive system and one is an active system. A passive system is mainly a system which takes in the solar gain from the heat and the sun rays coming in through the windows, heats up of something, and depends on the natural flow, the natural difference between the warm floor and the cool walls to help distribute the air and warm up the house. An active system is a system in which you have a thermostat or a fan or a combination of both, and some electrical systems pushing the air around actively. And in a passive system, let's look at the passive system, the second paragraph under passive. Underline, passive houses are designed so that their south walls, make sure that you understand it's the south wall is the main gain. South walls have a number of large windows. Read through the rest of that, and that will pretty much wrap up what we're going to talk about specifically in this lecture. Now I'd like to say, as I've gone through this book, I've done a lot of highlighting. I've asked you to read a lot. It's important that you also get not just what I've highlighted, but also the details. For in any good job, it's the details in a job that really makes a great job.